When people ask you about the data granularity, so you just need to understand what is the grain of your data first of all. So if you pull, you can describe it like this. Suppose I have a table, and if I pull the select some from that particular table, the grain of the data is right now at the lowest level. I am taking the complete total of the amount. So aggregation rule is the highest. Whenever we apply the highest aggregation rule, my data granularity will be the lowest one. So these are two opposite to each other. So you need to describe it properly. So this thing, once you can say the inverse relationship between the aggregation and the data granularity. Other thing is, so let's suppose I will bring some column here, a region column maybe. Okay, and I will put it somewhere on the color shelf or row shelf. So now you see data is again breaking up. It's going to a I'm bringing a dimension to define the granularity of the data is at the region level right now. And data start breaking up with each member present in the region column. Data is breaking up and showing up the value here. So right now the granularity of the data is at the region level. So as we bring the column, number of column, the granularity will keep on reducing. So it will go to a, the granularity will keep on increasing, but the aggregation rule can keep on decreasing. Now it's got aggregated with the lesser amount. So if I bring some other column, it again aggregate the data at the, lowest level, and granularity is keep on increasing. If I bring the product here, it is at the highest level of granularity, because maybe the dimension, the table is at which level? The table is the order ID level or the product level. So if I bring the order ID, so maybe the table is the order ID level. If I bring this order ID here, this is the highest level of granularity and the lowest level of aggregation. Lowest level of aggregation means I am seeing the record row by row present in my table right now. Okay. So these two things should be clear to you: the grain of the data and the aggregation it takes. So what it is doing is, it is doing the in the SQL terminology, I can say it is doing partitioning of the data, bucketing the data by the member present in the column, or the partitioning of the data it is doing. So this is what is called as data granularity in the Tableau, or you can say about the RDBMS or anything. So you need to understand the whenever the user give your requirement, because granularity is very much important. Why? Once you go in the real time scenario and start creating your report, you need to understand the grain of the report, how unique, at what level your data is coming as a unique data, so that you will aggregating, there is no duplicacy in your data. So for that you need to understand the grain of the data. Once you understand the data is at this level, you can ask, because the customer ask you the data has very different levels, they will ask you. So and you need to understand the grain of the data, and you need to tell them, is that possible what they were asking you to give you the data? Because maybe you have the data at the quarter level, and he may be asking your data at the day level, but your data in the table is at the quarter level. You can't go at the day level now, right? So you need to understand the grain of the data, where it lies, so that if the user asks you, I want the report like this, so you can tell them. So, or maybe the report is performing very slow, so you need to understand your report is at the year level, and you are hitting the table which is at the day level. So it is aggregating all the day level data and showing up at one particular year. So for 2020-21, I'm showing up the data, and 2020-21 have 365 days in the database. So it will club all the data for 365 days, and it will show in the UI. So it will somewhere keep the SQL and keep on running the database, right? So if the report is performing very slow, you can talk to the customer. So the grain of the data right now for the table is at the day level, and we were showing the report at the year level. Can we create another aggregate table at the year level? So data will be all ready in my table. I can just directly hit that particular table from the database, and data will be very faster and quicker. So those situation granularity, you need to communicate to the customer very frequently, or to the ETL team working with you, the framework team working with you. to do the changes. So that's the reason I'm raising this concern. This data granularity concept is very, very much important. Maybe some of the interview people may ask you, some may not, but in the real time scenario when you work, you need to understand the first of all the where your data lies, where is the what is the grain of the data. All right, so this is pretty much clear now. So the next topic that I was to take is a scatter plot. Let me browse one data set. Okay. Okay, so scatter plot. When we use the scatter plot, when we want to give the when we want to do the correlation analysis. So I discussed with you the composition, categorical, and comparative analysis, and the trend time series analysis we did. So this is the fifth type of analysis that we do is a correlation analysis. Suppose there are two variable, one is input, one is output. The input and output variable both are dependent on each other, and given the input, you want to know the output of the data. So generally, this type of analysis we do during the predictive analysis that we want to do, or the user is asking you to give you a trend equation or a predictive equation where he can substitute a data, or he want to know the trend of the data. Is it a linear, or is it the strength of the data that is going is a positive, negative, or there is no relation. So there are few things that we do, but just to understand, make it understand, is just learn a few things that scatter plot is generally used for the correlation analysis. First thing. Second thing is it is generally used for the predictive analysis. There are two variables, one is input, one is output. Based on the input, the output we define. What is the output? We can predict. Okay, if there is no relationship between the input and output, you can't figure out what is the predictive value coming in the future. Okay, so these things just keep in mind what is the correlation analysis and what is scatter plot, where we have to use. So I will take one example here. Suppose I have asked you the gain, the weight of the gain in the weight of the person. So when the calories, how much he has consumed, then only you can understand what is a person weight gain in the past 1 year, or maybe in the few days, how much he has gained the weight. That depend upon the calories he is consuming, right? So input is calories that I will provide, and you will give me the how much weight he has gained. So this is and these are two dependent variable on each other. Suppose I want to know the power output given the wind speed. The wind speed is given, and I want to know the power output. All right, this will show one value. I have told you one day, I guess. when we got two column on the row and column shifts, it will show the aggregate data at the highest level of aggregation. Right now it is showing up. As soon as I bring the windmill in the report, it will split up this data by a windmill. The level of aggregation is now the windmill, and the granularity is also being increased here. So right now it is the one value it is showing. Let's go to analysis and remove this. This is now the aggregate measure. Just uncheck that. You see the data is now all being scattered. What these values are coming up here? So much of values. It is a values which is present in the, if you go and right click and view data, it is showing all each and every plotting of values now. Previously, we are showing all the data like aggregation. Sum is applied on the power output, and it's showing the total value of this column. Now it is showing coordinating in the coordinate. It is showing each and every column mapping by this. Okay, so this is I got the value. So I got this value from the customer, the windmill, and the from the till now what they were maintaining the data, right? For the predictive analysis, if I go, I need to have the data what they have right now in the database. Then only on top of that, I will predict the trend what they have, what they were doing is, and what is the future of I can predict out of that, right? Suppose I'm running a business of 5 years. I got the 5 years of data. I can, with the 5 years of data, I can predict what the trend got reduced. The trend was an increasing curve or a declining curve. I will teach you the different types of positive negative strength we have. I will show you, but just understand right now this is what with the scatter plot, and the usage of the scatter plot is also clear, right? For the predictive analysis we use. So the next is the direction. So we have three types of direction in here. Let me open and share that image that are easy for me to okay. Can you see this MS Paint scatter plot? Is it visible, Ashok?
You can see it.
Thuria, is it visible?
Yeah, we can see it.
Okay, sure. So if you see with increase in input, suppose here the input is 1 and the output is also 1. Here when the input is 10, the output is also 10. So I can see it is going somewhere not straight, but somewhere it is going a straight, right? So this is called as a positive correlation, and we can say it's a going a direct relationship between the input and output variable, because it's a straight line going. Suppose this is also with this I can correlate it. This is also positive correlation. It is going in a positive direction. But can you predict with this diagram what is the relationship here? I can't predict. I can say it is going down. I can say it is going up. I can't predict here, right? So this is called as no correlation, where I can't predict what is happening with my input and output data. Okay, in that situation, we tell to the customer that there is no the input, the data that you have provided, there is no relationship in that. There is no correlation between the data that you have provided. Means I'm asking you the weight of the person given the wind speed. I have given the wind speed, and now I'm asking you, can you give me the weight of the person? Because there is no relationship, how you can give me that? So you can tell to the customer there is no correlation between the data. I can't predict on this data. All right, this is called as no correlation. So you understand the positive. Similarly, the negative is given the input, output may decrease. So it's a going a negative direction, going downwards. So this is the negative correlation. This is curvilinear, maybe a polynomial kind of thing. It is the curvilinear relationship. Yeah, we will discuss that the curve because it is like this. It is showing the highs and the lows, in the graph. So this is called curvilinear relationship, or sometimes it's called polynomial relationship. So are you guys clear with the strength? So when we define a trend line is composed of two things. One is its strength, and other thing is the direction. So I talk about a direction, a positive, negative, more correlation. These are the direction, and strength is a strong, moderate, and weak. So this is strong, but direction is positive. This is moderate, and direction is also positive. This is no correlation. This is moderate. Why it is moderate is because when the trend line I'm creating here like this, I will take some data points, W will take some data point, create a trend line. And if you see, there are few data point which is far away from my data. See, this data is very far away. These data points are very far away. So here I can say this is called as moderate, the strength is moderate, and it is direction is negative. It is going in a negative direction. So that direction are four types: positive, negative, no correlation, and a curvilinear relationship. But the strength are three types only: strong, moderate, and the weak. When you have weak relationship, you can understand there is nothing is happening here. And you can because I will tell you that when you create a trend line, there are few parameters with the help of that we can define the with the strength and direction of the trend line. But just understand the types right now. This is more of a theoretical. When we go into the in the workbook, there I will explain you from which value you can define, or significant these values. All right. So I hope I'm clear here. The directions and the strength. There are four types of direction and three kind of strength. Direction are positive, negative, positive, negative, no correlation, and the curvilinear relationship. These are directions. And what are strength is strong, moderate, and weak. Weak is not here, but understand weak is also. You can see the correlation one is a weak, because here nothing, no data, nothing, and even the R square value and the P values for this also will not be good. So I can say this no correlation is a weak data. All right. So I will share my workbook again. All right. So now how you will get a trend line? So can anyone give me the example of the positive correlation?
Yeah, this is strong positive correlation because all the points are close to each other. And
an example again from the cells, from this we have this, right? From here we can say any positive relationship.
maybe
Maybe
sales and profit.
Correct. Sales and profit, because profit is depend upon the sales, right? If the sales will increase, profit will increase. So that is positive correlation. And negative correlation, can you give me the example of negative out of this?
Discount profit, maybe.
Yeah, discount profit. Because when the discount I will increase, suppose, let me open the MS Paint. There I can again explain you. All right. You can see this MS Paint right now, right? Okay. So what I'm trying to say is sales and profit. Sales is an input variable. If I'm increasing my sales, profit will also increase, right? So it will be the positive correlation. If I'm increasing anything, this is also increasing. If I decreasing anything, this will also decrease, right? So sales here and profit here, these are positive correlation. But what I'm talking about is a discount and profit. Suppose here I gave 10% discount. Discount is less, so profit will be more, right? So somewhere I will get more profit. Suppose here I gave 60% discount, profit will be less now. Somewhere here I will less. So if I plot this, it will be a downward line, somewhere it will come. So this is what is called as it is coming downward, a negative slope will come, because increasing my discount, the profit will decrease. If you go to any of the store providing you 70% off, and if you go to a store which is there is no off, definitely with 70% off you will save a lot of money, right? And definitely the profit to the person who are you paying will be less, and the store you're going, the profit will be larger there, right? The person who is having lesser discount, definitely they will provide you the person will have the more profit. So discount and profit are inverse relationship, that is a negative correlation. Sales and profit is a positive relationship, that is the positive slope you will find. Okay. So here is, can you see again the tableau workbook?
No, we are still on.
Okay, let me, maybe I need to share again. Okay, now hopefully everyone was able to see.
Yes, we can see.
Okay, thanks. So how to get a trend line? So when you click on this graph, right, just right click on that, you will get a trend line option. Just click on show trend lines. If you see each what is happening in each data that you have, right, it also has a trend line, and Tableau internally creates hundred of trend lines, like not 100, the number of data points I have, it will create a trend line for each, and it will figure out a best fit trend line after considering all the data sets, combining trend line of all the data sets, it will give you one trend line here. Okay, and now the question is, with this trend line, how I can understand my model? This is scatter plot, but I got a trend line. Now with this trend line, how do I understand my model? So there are two things. If you hover on this trend line, you will see an equation where you have seen this equation previously, maybe in mathematics. Y is equals to mx plus c. That is, m is a slope here, c is a constant, right? The y is the output, m is a slope, and x is the input, plus c is a plus minus is a constant value that it is doing. So what is slope here? In this equation, power output equals to this. What is the slope here? No answers. You can't understand. Why is it, can you see this workbook, right?
Yes, we can see.
So what is the slope? No, right now.
Is there any formula to calculate a slope or directly?
So if you see,
it's the rate of change that we notice here in the power output per every in the increase of wind speed.
Yeah. So what is slope here? Can you see this on hover a tooltip is coming up?
Yeah.
Power equals to mx, like the value in front of it is one constant into wind speed plus c. So y is equals to mx plus c. Can you understand this equation here?
Okay. Yes.
Power output is y equals to the integer value or the floating value that you were showing in the wind speed, along with the wind speed, that is slope m.
Yeah.
Wind speed is a x, that is an input variable, plus minus c. So Tableau has already created an equation, predictive equation for us to understand whenever the user is now providing you an input. So with this, so okay, let me ask, suppose let me remove this trend line for now. All right, I've removed the trend line. So suppose I will ask you. I have given user. He has given you his data. Now is the question is, I have 10 milliseconds of wind. Can you tell me what will the power output? So you will go into data 10 millisecond. Okay, the data is in my range right now. I can tell him, okay, somewhere it will go to 15 megawatt till 15 megawatt. You will get the power output. I can tell him this thing. Okay. Suppose he will ask me, the data output I have given is a 15. Can you give me the power output? 15 also I can give him, right? I will. Okay. So if I go 15 till 15 also, I can see the power output. Approximately you will get in, between 29 or something, 29 megawatt. So that is also doable. But suppose if he'll ask you, can you give me for 20 millisecond wind speed? Can you tell me what is my power output? You can't tell him, right? Because it is not there in the input data that he has provided. Now you need to do the predictive analysis based on the input data that he has given to you. So first of all, you need to understand. First of all, you need to, with the data set, you need to understand is the data is correlated. Okay, data is correlated, and if there is no correlation, just tell them if the data you have provided, I can't do the significant analysis with that. This data is not suitable for the predictive analysis. You can directly tell him. But now I can see there is a correlation between the data. It's positive, right? So with this data, definitely I can give him the answer. So in that situation, for the predictive analysis, now you need to go and show the trend line. You need to go and click on the trend line here. And it will W will give the one predictive equation based on that. You can tell him, but not based on that. I can tell him there are again two things which come in the picture. One is R square, one is P value. So I told you when we have the trend line has two properties. One is direction, other is a strength. Okay, so direction here is what? What is direction here is? Slope will tell you the direction. What is slope here is 2.24418 is a slope. That is M in the mathematics that we go is equals to Y is equal to MSC. MX plus is a equation of the straight line, and equation of straight line is being used here. All right. So 2.24418 is a slope. Slope is tell you the direction. So direction is
2.24.
correct. So I can see the direction here is positive.
Yeah.
All right. And what value will tell you the strength out of this? R square value will tell you the strength. Just note it down. When the value of R square is greater than 0.8, that means the model is very good. That is called as the strong model. Greater than 0.8 is a strong model. Just note it down. I will share the recording also. Maybe in the G Drive, I will upload all the recording what I have till now. But just learn this thing, because this will not be as useful unless and until you will not understand the slope and the R square value coming from the trend line. All right, here R square value is 0.95, which is very far ahead from 0.8. So this is very good model. The linear model is very good fit for this kind of data, I could say. So R square value when greater than 0.8 is a strong. Between 0.65 to 0.8 is a moderate. So there are three kind of, I told you the strength, right? One is strong, moderate, and weak. So strong is greater than 0.8, and moderate is in between 0.65 to 0.8, and the weak is less than 0.65. So you please note it down these values, because you may forget the values. And it's very important. They will ask you this question in an interview. What is trend line in Tableau? So you need to describe them. What is trend line? First of all, tell them we need to do the predictive analysis for the trend equation. I need to use this trend line thing. And suppose a user has given me the input. I need to find out the output of the data. I can create a scatter plot. and have the trend line equation on that. But when we go for trend line, it has two properties. One is direction and the strength. So direction I have told you, strength also I have told you. There is a slope. When we create a trend line, the types of trend line, I will tell you what are the different types of trend line we have. But this is just a simple one, a linear trend line. So it has again the two properties, slope, that is define direction of the data, and the R square value, which will define the direction of data, and this is R square value will define the strength of the data. So here strength is a very good, strong, because it is greater than 0.8. But if somewhere it is coming between 0.65 to 0.8, it is moderate. And when it will come to less than 0.65, it is weak, right? So you got the from this on overall tooltip, you can see the direction and the strength of the data. So when we see, okay, this data is fit, and I can create this data is fit for my predictive analysis. And now if the user asks you the same thing, when I have 50 is my wind speed I'm providing, what will be my output? Now with this equation, put 50 here, you will understand in this equation, y is equals to y is the output, power output is equals to m 2.24418 into wind speed. Into wind speed is a 50 here. Just put it here, and plus minus here you can say some values is there, minus 6.4539. So if you put this value, you will get the output for the 50 millisecond, right? Now, are you able to understand, guys? Are you able to understand?
Yes, Kunal.
Yeah,
it
it
is.
is.
Yeah.
Okay.
Yes.
Okay, good. So if you have any doubt, just stop me, or maybe in the end you can ask me all the question if you have any doubts. Just note it down your doubts if you have. And when we close this at the end, you can ask me all your doubts again. I will explain you. But these are the very important topics to clear the interview process. So that's why I'm stretching a lot, again explaining each and everything. So suppose I user asks you wind speed is 50 here. So can anyone calculate and tell me what is the power output with this equation?
So we can replace that wind speed with 50 and multiply 2.2448 times.
Can you calculate and tell me?
Around 104 or something we get.
Okay, around 104 we will get, right? So when we go and do the predictive analysis also, we will not give the because we are doing prediction, we can't tell you the accurate value there also. So there is this called as a confidence band. Here right now this linear equation which is built having the confidence band of 95%. When you have the confidence band of the 95%, the 5% fluctuation that I have, the confidence band is, I'm telling you the data is 95% accurate, but the 5% that fluctuation I have left, the data what you were told me is 104, right? So I can do 5% of 104 is how much? I will, what the value which I got, suppose I will get 10 or maybe 5. I will subtract from 104 the 5, and I will add 104 plus 5. I will do minus 5 and I will do plus 5 to it. But before that, I will calculate the 5% of the output that you have told me, this, which is 104. The power output here is 104. When you keep 50 in the wind speed here, in this equation, you will get power output equals to y equals to 104. I will not go to client and tell you, definitely you will get 104. I will give the range of value there. And that's the reason confidence band will come in the picture. This is right now, this is by default work with the 95% confidence. 95% I'm sure your data will be accurate, but 5% I'm giving you a chance it may not, and I will fluctuate the data in the range with that 5%. So the 404 into 5% I will get one value. Maybe I will get 10 out when I do multiplication. I'm not doing right now, I'm telling you just blindly. Maybe I will get 104 into 5% I will get equals to 10. So from 104 I will do plus 10, and I will do -10 also. So it will be somewhere between 94 to 114. So I will tell them your data somewhere will come if you give the 50%, 50 millisecond of the wind speed, meter per second, the wind speed, your this thing will